Hello, and welcome to FSC iCalc's tutorial on density curve calculations. This applet is for determining the required density and required area of sprinkler operation in a system design according to the density area method of section 11.2.3.2 in NFPA 13. It helps you check for adjustments and exceptions and places your design requirements on a curve corresponding to your occupancy classification. The first thing we want to do is open up our density curve page on iCalc. You'll need to have a paid account in order to use density curve. If you don't have one right now, that's okay. You can get one for a month for free without entering your card information by just signing up. Go ahead and do that now if you haven't, and meet me back here. So let's begin with discussing what the density area method is. There are different methods for calculating the total amount of water required for a system, including special design, room design method, and pipe schedule. Density area is what you want for most situations, but discretion is required to make that call. Let's go over a few of the other methods just for context. Pipe schedule is still a valid method, though it is a bit older and rarely used anymore, as it tends to make less economical systems. Room design method is based on the number of sprinklers operating in a room, given that it is the most hydraulically demanding room. You should see section 11.2.3.3 and section 12.10 for more information on this. It might be good for a building with a lot of small rooms in a corridor. Then there's special design methods, which can be implemented in residential situations for exposure protection, water curtains, and certain wooded concealed spaces. See section 11.3 for more information on these. The density area method being the most common, it is what iCalc is designed to work with. It starts with a set of curves shown in figure 11.2.3.1.1. This corresponds to light, ordinary 1 and 2, and extra 1 and 2 hazard groups. Any point on these curves is a valid configuration, so designer may make decisions between high and low area points on the individual curves. A low point provides a smaller operating area, giving a higher density but a lower total water demand. A higher point provides for a lower density and therefore lower pressure, but typically requires a higher total demand for the system. iCalc lets you adjust your point on the curve by entering in what area you require. It will also force your design to fit on the curve if you enter in an invalid area. So make sure you pay attention to the output readout. It will tell you when your area is being adjusted to fit the curve. So let's run through some example situations. I'll select an ordinary 1 type hazard with an area of 3,500 square feet. This will be a wet system with a ceiling height of 10 feet and a slope of 0. We will not have a quick response sprinkler system or any unprotected combustible concealed spaces. I'll hit process data. As you can see, this is an easy example. There were no adjustments or exceptions to account for, so iCalc simply matched the point on the ordinary 1 curve for 3,500 square feet. This gave us a density of 0.11 gallons per minute per square foot. Let's try this again with some curveballs thrown in. Let's pretend I want an operating area of 1,200 square feet, and it's going to be a dry system. I'll make these changes to the inputs and hit process data. We can see that iCalc has changed our area input from 1,200 to 1,500 to fit in the range of the ordinary 1 curve. Additionally, it has adjusted the final operating area to 1,950 square feet while keeping the density at its original position. This is because section 11.2.3.2.5 requires dry systems to increase the area of sprinkler operation by 30% without revision to density. NFPA added this because it takes longer for a dry pipe system to get water on the fire, and this delay tends to let fires get larger. To compensate, a designer must account for a larger area of operation. Let's move on to our third example. For this, we're going to do a more intricate situation. We'll leave the occupancy and area alone, but change the system type back to wet. Then I'll set the ceiling height to 15 feet and the ceiling slope to 17%, and add quick response sprinklers to the system. Hitting process data, we see that we get an interesting adjusted area figure of 1316.25 square feet. This is accounting for 2 major adjustments. Let's work through what those are. Quick response sprinklers. See section 11.2.3.2.3.1. It dictates that if quick response sprinklers are used in a light or ordinary hazard with a wet pipe system under 20-foot ceilings with no unprotected combustible concealed spaces, that the operating area may then be reduced by a ratio calculated from a capped set of ratios ranging from 25 to 40%. These ratios are based on the ceiling height, and in our case, this reduction would come out to 32.5%. This brings our area down to 1012.5 square feet. Then we have another adjustment, and this is for slope. In section 11.2.3.2.4, it dictates area must be adjusted by 30% if the slope exceeds a factor of 2 and 12, which we have done here. This brings our area to 1316.25 after accounting for the quick response sprinklers. After that's all calculated, it retains the original density of 0.11 gallons per minute per square foot as indicated by the graph. Eventually, iCalc will reference all these rules for you as it uses them, so it'll be easier to spot check yourself and ensure you're not missing something in your calculations. This is the first version of the density curve applet, so it doesn't have the citation feature yet, but look out for it in an update very soon. Alright, that's all for today's tutorial. I hope you found this video helpful. If you still have any questions, you can reach us by going to the contact page on the iCalc website or by emailing support@fscinc.com, and I'll leave both those links in the description. Thanks for watching. Make sure to subscribe and check out our other videos.